Hello everybody and welcome back for more of the Hypatia math contest. We're looking at question number 2 on the 2011 paper in this video, so let's take a gander. Hopefully we've got our pencils and erasers ready, because we're mathematicians and we do occasionally make mistakes, so you shouldn't be working in pen. So question 2 here. A set S consists of all two-digit numbers such that no number contains a digit of 0 or 9, and no number is a multiple of 11. I could actually write all these out if I wanted to. Okay. But, and maybe we will, but let's take a look here. A, determine how many numbers in S have 3 as their tens digit. Well, this isn't that hard. You know, what are the numbers, the two-digit numbers that have 3 as their tens digit? And we'll just get rid of the ones that don't satisfy the criterion. So we can't have a 0 or a 9 anywhere. No 0, no 9. And we can't have a multiple of 11. Well, there's only one multiple of 11. That's 33. So were we asked what are or how many? Determine how many numbers. So, well, I'll just count here. 1, 2, 3, 4, 5, 6, 7. There are 7 numbers. And I think if I wrote this out, it's only question 2. But I think if I just wrote this out and you saw the things crossed out, you would be perfectly happy to give me all the marks there. If you really wanted to, you could write a tiny little, we're crossing this one out because it's got a 0 in it, but don't bother with that sort of stuff. It's part A. We're just sort of getting accustomed to the rules here. B and C, probably a little harder. D, maybe there's something to it. But D, determine how many numbers in S have an 8 as their ones digit. Okay. An 8 as their ones digit. Well, what two-digit numbers can I have that have 8 as their ones digit? 4, 8, 5, 8, 6, 8, 7, 8, 8, 8, 9, 8. And that's it. But no 9's digit. If we were using 0, 8, there'd be no 0's digit, but don't worry about that. No multiples of 11. So we've got 1, 2, 3, 4, 5, 6, 7. Hey, we got 7 as well. I wonder if we isolate based on digits, we'll always get something like 7. Maybe it'll work, maybe it won't, I don't know. Determine how many numbers are in S. Jeez. So, determine how many numbers are in S. Well, as I've said, I could just list them all out. And, that's not going to be terrible. I think that's why this is a question 2. Because if you need to brute force it, you can, and you can still get marks. And I understand they like to sort of, at the halfway point, and then they start doing the theory that if you don't understand what we're talking about, you can't just list all this out. You can't just try all possibilities. You can't just draw all pictures and get it. But with this one, I think absolutely. If you want to take the time, write out all the two-digit numbers, cross out the ones that don't work, you could do how many numbers are in S. And D part, which I'm just reading now, determine the sum. Yeah, it's going to take you a lot of time, but you can do it. Okay, so that would be one way to do it. I think a faster way to do it, just based on the conditions that make up S, no number can do this, no number can do that. I think the faster way to do it is just say, well, how many two-digit numbers are there? And get rid of all the numbers that, and count how many numbers satisfy these properties right here. Okay, so how many two-digit numbers are there? There are, so there's 99 minus 10 inclusive, so 90 two-digit numbers. Okay, how many of them are multiples of 11? There are 9 multiples of 11. Namely 11, 22, 33. Yeah, I'm listing things out, but it's going to be a shorter list, I think, than if I were to list all the numbers that are actually included. How many numbers have a 9 in them? Oh, now that's a little harder. Well, let's do the how many numbers have a 0 in them. 10, 20, 30, 40, 50, 60, 70, 80, 90. So there are 9 that have a 0. And then in terms of the ones that have 9, there's the 19, 29 through 99, and there's 9 of those. And then, of course, there's the 90 through 99, and there's 10 of those. 99 is the only one who's on both lists. So 18 have a 9 in them. But we've counted 90 twice, and we've counted 99 twice. Minus 2 for counting, and I would write this out, counting 90 and 99 a second time. And as long as we're careful and haven't counted something else twice, and we can actually ask ourselves, okay, I need a 2-digit number that satisfies a couple of these conditions. It needs to have a 0 and be a multiple of 11. Well, that's not going to happen. It needs to have a 9 and be a multiple of 11. It's going to have to be 99. It needs to have a 9 and a 0. Well, you can't have 0, 9, but you can have 9, 0. So these are the only 2 that would appear on multiple lists. So we're going to do, so this is 18 plus 18 is 36 minus 2, so 34 numbers not allowed in S. So S has 90 minus 34, which is, take away a 6, you get an 8, so 56 numbers. Okay, and D part was what? Add them all up? Yeah, D part. Determine the sum of all the numbers in S. Oh, you know what? 56 right there is 7 times 8. So if I had just done the how many start with a 1, how many start with a 2, how many start with a... I'm pretty sure I would have gotten 7 for each of them. And you can only start with a 1, 2, 3, 4, 5, 6, 7, or 8. So that'd be another way to do it. So, determine the sum. Well, I could do it, I guess the way they intended is to add up all the 30s and so forth. But I think adding up all the numbers from 10 to 90 and then subtracting because I actually have the list of the ones that I don't want. So just subtracting off that list would be perfectly fine. Okay. So to sum S, we'll add all the numbers from 10 to 99. Actually, we don't need the 90s in there. So 10 to 89. And subtract off 10, 11, 19. This is getting complicated. And so on. Is there a better way to do this? So I'll keep that in my back pocket, but $10, 11, 19. The fact that we've got 9 and 0 chosen is quite bizarre. I think I did see sort of the wrong way to motivate D. So I think let's say so let Let A equal 1, 2, up to 8. We're going to say there are 7 numbers in S that start with A. So we're going to have A0, A1, yada, yada, yada. AA will be one of these, and then we'll keep going. Da-da-da-da. A9. Now there's 10 of these, but we can't have A0, we can't have AA, we can't have A9. 3 of these, so 7 numbers, just like part A did. And so since there's 8 of those, then the 7 times 8, 56. That would get us the answer that we got for C part. Anyway, so that's just like a little aside. Now, let B be any of these numbers. There are 7 in S ending in B. So we've got, we can't have 0B, but we can have 1B, 2B, yada, 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 BB, and 9B. But you can't have BB, can't have 9B, and there are 9 of these, 2 of these, so 7. Okay. So now, for making my sum, so the sum of the S's is going to be, there are 7 times 80 for each A equals 1 through 8, and there are 7 single digits B for each B from 1 to 8. Now I can add these up. So the sum of S is 7, there's 10 plus 20, all the way up to 80. And here we have 7, 1 plus 2, all the way up to 8. I can actually work these out. One of them is just going to be 10 times the other. So 1 plus 2, so this is, 7 is, so 28, so we get 36 here. So 7 times 36, and 7 times 360. So the fast way to do that, by the way, up to a certain number of numbers, so 1 plus 2 all the way up to n is n times n plus 1 over 2. This is something that comes up a lot. They're called triangular numbers. It's a formula you really should know. But if I plug in 8 there, 8 times 8 plus 1 is 8 times 9 over 2, 4 times 9, 36. Okay? So now we just sort of need to add these up. And 36 plus 360 is 396 times 7, 2772. So that's my sum for S. And yeah, it seemed a little rushed, but there's not a whole lot to these ones, and I do admit I sort of got off to the wrong foot in C part there. But overall, not a bad question. Very interesting defining this set S, and I hope the rest of the contest continues to be this interesting. But that's it for question 2. Join me in the next video for question number 3.